Hi guys, I'm Chastity and I'll be continuing my group's discussion on the topic from cells to organs by discussing bone marrow. So by the end of this presentation, I hope that you will better understand what bone marrow is, be able to list the components of bone marrow, define the function of bone marrow, and discuss abnormalities that could affect bone marrow production and or function. Going back to that second objective, with listing the components, hopefully you'll be able to list the major components of bone marrow. In this image, you're given just a brief overview of bone anatomy, so it's something that I want you to keep in mind as we continue with our discussion. What is bone marrow? So bone marrow is flexible tissue in the interior of our bones, and that flexible tissue is made up of a soft fatty substance. Bone marrow is found mostly in the bones of thighs and hips, but could be found in any of the flat bones, for example, the sternum. There are two main types of bone marrow, red bone marrow and yellow bone marrow. The naming is indicative of the color, and the color is due to the components that make up each type of bone marrow. At birth, all of the bone marrow in the body is red, and with aging, that red marrow converts to yellow marrow. Both types of marrow, red and yellow, are highly vascular. They're both enriched with numerous blood vessels and capillaries, which is important because daily bone marrow makes nearly 200 billion new blood cells. It's also important to know that most of the blood cells in the body develop from cells in the bone marrow. That leads us to discussing components of bone marrow. In this image, you see that essentially bone marrow is responsible for many different types of cells. Of course, this is overly simplified, but it's just to show you that bone marrow makes a lot of stuff. So what are those components of bone marrow? Bone marrow is made of stem cells, and not just any stem cells, but two types of stem cells specifically. Hematopoietic stem cells made from our red marrow and mesenchymal stem cells made from the yellow marrow. I know Aziz has already discussed stem cells, but we're going to review just to ensure that everyone understands these two types of stem cells. So first we're going to start with the hematopoietic stem cells, or the stem cells that you get from red bone marrow. The stem cells from red bone marrow are our blood forming stem cells, hence hematopoietic stem cells. It's delicate, highly vascular fibrous tissue within those red blood cells, and that tissue gives you red blood cells, white blood cells, and platelets. Red blood cells, or erythrocytes, are responsible for transporting oxygen around the body. White blood cells, or leukocytes, happen to be the cornerstone of the immune system, um, very, very essential for the lymphatic system, which we'll discuss later. And then platelets, also known as thrombocytes, which are responsible for clotting after injury and happen to be fragments of megakaryocytes, which are a smaller type of cell made within the bone marrow. So this image just reviews everything I just said. Starting with the red bone marrow, you get hematopoietic stem cells. Those hematopoietic stem cells give rise to lymphoid progenitor cells and myeloid progenitor cells. Those lymphoid cells give you your B cells and T cells, which you know of their role thanks to Aziz. And the myeloid cells are where we get the erythrocytes, platelets, and also other things like eosinophils, basophils, and neutrophils, which happen to also function with immunity. Mesenchymal stem cells, which are the stem cells that we get from the yellow marrow, are also known as stromal cells. So from these cells, we get the production of fat, cartilage, and bone. The chondrocytes made from these cells are what give us the cartilage generation, osteoblasts, bone formation, adipocytes, fat tissue, and myocytes, muscle. So it's important to know that from these mesenchymal stem cells and these hematopoietic stem cells, they're different from other blood cells because of their renewal and differentiation properties given to them as stem cells. One thing to go back to, those myeloid and lymphoid cells that are generated from the hematopoietic stem cells are called pluripotent stem cells. The mesenchymal stem cells are multipotent stem cells. So enough about stem cells. Now let's talk about what bone marrow does for our body. If nothing else, the discussion of stem cells should hint at the importance of bone marrow and its functions within our body. Majority of the red blood cells, platelets, and most white blood cells are formed in the red marrow. All of these cells have to be constantly replaced. Because these cells need to be constantly replaced, we know they're essential to survival for almost every organ. The constant production of these cells is something that needs to be controlled. So we can control red blood cells with a hormone from the kidney. We can control white blood cells and also platelets. So for control of red blood cells, it's stimulated by the hormone erythropoietin, which is found in the kidneys. So in some type of event, such as anemia, you would have the kidneys stimulate the production of EPO, and that production would stimulate more production of red blood cells. Similarly, in the presence of infection, more white cells would be produced, and with bleeding, more platelets would be produced. Earlier in the slide, we mentioned that when you're born or at birth, most of the marrow, or all of the marrow, I'm sorry, is red bone marrow. Um, and with aging, you get these large amounts of yellow marrow. It's important to note that yellow marrow can be activated and transformed into red marrow. So, yes, as you age, you have less red bone marrow, but the yellow marrow can be converted to red marrow to help with the continuous production of those red marrow products. This process, or this activation of yellow marrow to red marrow, decreases with age, but it's something that can happen. Bone marrow, as I said earlier, is necessary for the proper function of multiple systems because bone marrow gives rise to the cells that fuel these systems. So, two systems specifically would be the circulatory system and the lymphatic system. With the circulatory system, we know that the circulatory system is just the movement of oxygen and blood throughout the body. And without the continuous production of those red marrow products, our circulatory system would not function properly. The lymphatic system, bone marrow is a key component of our lymphoid organs because bone marrow is able to generate lymphocytes from those immature hematopoietic stem cells. Bone marrow is also important for hemoglobin production and iron production, which makes sense because we need bone marrow to continually produce those red marrow products. So in this slide, it's summarizing what we said, which is that bone marrow is essential for the proper functioning of nearly every system within our body. So what happens if there's a problem with bone marrow? Bone marrow can be affected by pathologic states such as malignancies and aplastic anemia. Bone marrow can be infected by infections such as tuberculosis. And any of these, the pathologic or the infections, lead to a decrease in the production of blood cells and blood platelets. Um, Malignancy can also be an abnormality with blood cells, and those progenitor cells, specifically those hematopoietic stem cells, can turn malignant in our bone marrow, causing leukemias, something that most of us are familiar with. Another thing that could affect our bone marrow or cause an abnormality with bone marrow is exposure to radiation or chemotherapy. Because radiation and chemotherapy is essentially killing cells within our body, it will kill many of the rapidly dividing cells of the bone marrow. This process could lead to malignancy, which would then lead to things like leukemia, and it could also result in depressed immunity because those necessary cells are constantly being killed off. So, bone marrow is essential to life. And if we're thinking from cells to organs, bone marrow is responsible for the creation of the cells that fuel our body system. So, it fuels our organs. Bone marrow gives us things like red blood cells, white blood cells, platelets, cartilage, bone, and fat. All things that are essential to the proper function of our organ systems. Stay tuned and keep watching as Allison discusses the last part of From Cells to Organs.